My dear friend, Professor Ramesh Thakur from Central University of Himachal Pradesh, Dr. Malkir ji, also from Central University of Himachal Pradesh, my dear colleagues of DAV College Kangra, and my dear students. First of all, I am thankful to the organizers of this conference that they have invited me to interact with all of you. So, dear friends, this topic I have chosen because, this is a very generic topic and this is not something like rocket science. So, I hope that in next 40 to 45 minutes you will find it interesting, and some of the students, those who might have planned to go for higher studies like PhD programs, they would also be thinking on these lines. Okay, so dear friends, I have chosen the topic sustainable and hybrid electrolytes for future energy storage applications. So when we talk about electrolytes, so you might have studied, because I have been told that students from science like physics, chemistry, biological sciences, they are sitting in this hall. So you might have studied in your 12th classes, if you are not studying chemistry right now, that how basically a battery works. And when a battery works, so electrolyte is one of the very, very important component that defines, that signifies the life cycle of the battery and how efficiently the battery works. So that is also being decided by the electrolyte. So dear friends, you might have come across with these sort of incidents. Might be from social media or might be from news articles, that electric vehicles which are consisting of batteries, particularly lithium-ion batteries, and even your gadgets which all of us are using, they are suddenly exploding. So anyone of you have tried why this is happening? So anyone who can respond for this question? Because you might have seen all these images in the social media or in news articles. Anyone you might have thought of, जिसने इसके बारे में सोचा हो या why this is happening so. And this is going to be very, very serious problem in the times to come, because now the coming era is of the era of electronic gadgets, and all of us will be using all these electronic gadgets, and that electronic gadgets surely would be consisting of one of the very important component, that is battery component. तो कभी जानने की कोशिश की कि why this is happening so? तो मैंने इसके बारे में सोचा, मेरे स्टूडेंट्स ने इसके बारे में सोचा कि why this is happening so, and as a chemistry or as a member of scientific community, how we can overcome this problem, how we can save the humanity from all these incidents. So dear friends, this is a very simple problem statement, that the battery component, which is consisting of one of the very important component, तो ठीक हो रहा है, जो नहीं हो रहा वो भी सही हो रहा है, ऐसा है क्या? So dear friends, each and every energy storage device, that device is consisting of a battery, and that battery is consisting of one of the very important component, that is electrolyte. So in the existing electronic gadgets or any of the energy storage device, very flammable, thermally unstable organic carbonates are being consisting or constituting this one of the very important component, that is electrolyte. So मैंने ये सोचा कि ये जो harmful, highly flammable, highly thermally unstable, अगर इन solvents को हम replace कर दें eco friendly green solvent से, तो क्या हम इस तरह के incidents को रोक सकते हैं क्या? So my group and me, we worked on one of the very innovative solution, that let us substitute the solvents which are basically leading to these type of incidents in one or other type of energy storage devices. So in this lecture, I would be talking to you that how we can save the humanity from these sort of incidents or accidents
because the coming era would be the era of electronic gadgets, electric vehicles. So it is very, very important to make that battery component safe, environment friendly, because once electric vehicle is lifespan is over, then what we are going to do with that battery? The battery, there would be a huge chunk of battery components in the times to come. And if that battery component is consisting of harmful solvents, harmful chemicals, then again they would be disturbing our land and water resources. So I am working on the two problems simultaneously. One, that let us make the electronic gadgets as well as electric vehicles safe, and other, let us contribute to make this, to keep this planet safe and environment friendly. So I would be talking on a very simple problem, that how these harmful, highly flammable, highly thermal unstable solvents can be substituted with the eco-friendly green solvents, or the solvents which are not causing these sort of incidents. So all energy storage devices consisting of one of the very important component that I have talked to you, that is electrolyte, and this electrolyte is basically consisting of very harmful carbonates. So those carbonates need to be replaced, because these highly flammable, thermally unstable solvents need to be replaced with some of the eco-friendly and thermally stable and less flammable solvents. So this is also the growing demand for sustainable energy solutions, and all we are shifting towards towards the resources, towards the gadgets which are basically eco-friendly. Once these gadgets or electric vehicles are of no use, the batteries which are going to be of no use, how these batteries are to be disposed of, how our resources like land and water, they can be kept safe. So let us work on these very small problems, so that we can contribute something towards the society as well. So there is a need for sustainable energy storage, because depletion of fuels is taking place, population is growing like anything, and automatically that would be leading to growing pollution as well. So coming era would be the era of electric vehicles, because we would be substituting the existing fuels which we are using. So when we are switching over towards electric vehicles, then it becomes very, very important for all of us that let us keep our electric vehicles safe, because passengers and human beings, they would also be traveling through those vehicles also. So the incidents, they should not take place like which we have shown in the first slide. Next. Okay. So when we are talking about green transportation, so of course we would also be talking about the electric vehicles, so which also not be using the existing fuels which we are using, because they are causing pollution and creating problems for the environment also. So these would be helping us in reducing carbon footprint. They are basically the cleaner form of energy storage, and it would also be helping in the reduction of depletion of fossil fuels as well. And of course they would also be creating less noise pollution, because many of you might have traveled through electric vehicles or the Volvo buses which are consisting of electric vehicles which are not being using the existing fuels, so noise is very less. So when we talk about different energy storage devices, so these are few, all of you know that what basically we mean by energy storage devices. So when energy storage devices are being talked about, so we have batteries which are being used in various industries, including consumer electronics, gadgets, electric vehicles, and grid-scale energy storage. But there are few of the challenges which are being associated with the existing battery system, or the existing batteries, or particularly lithium-ion batteries which we are using in electric vehicles or electronic gadgets. So they are basically having certain problems, like they have very good energy density, but that device is struggling with less power density. So these two terms are very, very important when we talk about any of the energy storage device. energy density, how much energy one of the device can store, and with how much time it can deliver energy, that is power density. So entire scientific community is working very hard because they are able to get devices with high energy density, but on the other side they are not able to get high power density devices. Similarly, when we talk about supercapacitors, so they have the limitation that they have less energy density, but their power density is very high. So again, we are struggling with the same problem. So we are not able to get the devices which have both energy density and power density higher. So entire world is working on कि हमारे पास ऐसा डिवाइस हो, ऐसा सिस्टम हो, ऐसा चार्जर हो जो 1 मिनट में चार्ज कर दे और 10 घंटे में डिस्चार्ज करे. यही कोशिश रहती है कि हमारा मोबाइल एकदम जल्दी से जल्दी चार्ज हो जाए और डिस्चार्ज होने में उसको ज्यादा से ज्यादा टाइम लगे. So entire world is working on this problem to reduce charging time and to extend discharging time. So again think on this problem, how this problem can be taken care, how we can increase both power and energy density simultaneously for any of the energy storage device. Problem statement आपके लिए ये. So we have many energy storage devices which we are using, like dye-sensitized solar cells, in which basically we use sunlight which is being converted into electrical energy through the interaction of sunlight with dye molecules and semiconductor materials and are used in solar panels. So these types of energy devices are not so much popular as compared to other, because there are certain challenges like stability issues, or there might be certain fluctuation problems of sunlight that we are not getting continuously the solar energy which we require for storing energy. Similarly, we have another type of batteries or energy storage devices which are consisting of flow batteries, which are basically using liquids as electrolytes, and similarly we have solid state batteries where basically we are using the electrolytes in the solid form. So again, this is a very simple, generic picture which you might have studied from 10th class, that how basically a battery works. बैटरी काम कैसे करती है, क्या क्या उसके कंपोनेंट हैं. So each battery component is consisting of 3 very important components. One is anode, other is cathode, and the third one is electrolyte. So me and my team is working on the electrolyte part. So after some time we are also switching towards the electrode materials, how we can make biomass based electrode materials. Presently we might have seen that we are using many metals which are basically constituting or forming electrodes, but we are now trying to use biomass to make these electrode materials. But right now, me and my group, they are working on the electrolyte part. Our problem statement is that we have to make our battery safe, environment friendly, so that it should not cause any harm to anyone. So these are the solvents, or these are the electrolytes which are basically creating problem for all of us. And these solvents which are being used in the existing storage devices, they are basically carbonates. So these carbonates are organic carbonate solvents, including ethylene carbonate, dimethylene carbonate, diethylene carbonate, and entire electrolytes which are being used. They are basically consisting of these type of solvents plus one of the salt of lithium. Please. So when we are using these type of electrolytes consisting of organic solvents, so they have many advantages as well, because these solvents, they have high ionic conductivity. These solvents, they have high electrochemical stability window. This is the voltage window where basically battery operates. So we cannot substitute so easily these organic solvents, because if we are substituting these organic solvents with any other type of solvent, there might be certain problems of we are encountering with in terms of viscosity, in terms of ionic conductivity, in terms of electrochemical stability window, because all these parameters, all these physico-chemical parameters, they are very, very important for deciding efficient and workable electrolyte for any of the battery or any of the energy storage device. So it is not so easy to substitute these existing solvents, which are highly flammable and are thermally unstable, leading to fire explosions sort of incidents. So we are trying to find certain other alternates so that we can substitute these harmful solvents. So these are the limitations which I have already explained. So now we are shifting from organic solvents to aqueous electrolytes. So when we talk about aqueous electrolytes, so of course water would be one of the very important component which is being used as solvent. But there is one problem, that ESW, electrochemical stability window, is low as compared to organic solvent. So we cannot so simply replace these organic solvents with water and simply we can constitute battery and that battery would be working efficiently. No, it is not so easy. So the scientists, they are also trying to find many other alternates, including aqueous electrolytes, where water is also one of the very important component. So when the water is the component being used as solvent in any of the energy storage device, so it means it is now little safer and is not going to cause any harm to any of the human being as well. But so it has a limitation that voltage window is of the range 1.23. So requirement is we have to reach basically this battery works, or lithium-ion battery works within 1.3 to 4 volt. So range is very peculiar and very important, where battery is basically working on, because in this window the electrolyte is not degrading, it is not being oxidized, it is not being reduced. So it is very important, to find certain alternates, to find the solvents or electrolytes which have the stability, electrochemical stability window of this range. So many people, they are also working on solid state electrolytes. So there are many problems associated with these types of solid state electrolytes, like interfacial resistance and fabrication complexity. So when we talk about interfacial resistance, so this sort of one layered solid electrolyte interface layer is being formed during the initial charging and discharging cycle of the battery. So ultimately there is a layer which is being acting, which is being creating problem when for the movement of lithium ions from one electrode to other electrodes. So that layer is basically restricting the movement of lithium ions to move from cathode to anode and then vice versa during discharging. So it is not so easy to use these solid state electrolytes also. So ionic liquid electrolytes, me and my group, we have chosen ionic liquid as one of the substitute for organic solvent. But using ionic liquid is also causing many problems. Ionic liquid is having very high stability window. It is not highly flammable, very less flammable. So, but there are certain problems which we are encountering with, that these ionic liquids, they have high viscosity. Cost of these ionic liquids is very high. It is not so simple that we can substitute organic solvents with ionic liquid. So we are trying to use ionic liquid as one of the component along with other components which are less costly, and we are trying to create certain other alternates in addition to this ionic liquid as well. So deep eutectic solvents. So this is also one of the very good choice, and we are also exploring the possibility of using deep eutectic solvents also as one of the alternate to existing organic solvents. Dear friends, deep eutectic solvents is the coming future when we are talking about the energy storage applications or energy storage devices. Because these deep eutectic solvents, they are eco-friendly, are being treated as green solvents. So when I was talking to you, then when one battery is being disposed of, consisting of harmful and flammable solvents consisting of carbonates. So our resources like land and water resources, they are being deuterated and they are being they are being polluted because of the disposal of the batteries. So that's why let us make these batteries consisting of some eco-friendly or green solvents, so that during their disposal we should not be able to create any harm to our resources like land and water resources. So when we talk about these deconducting solvents, so these solvents are basically consisting of two very important components. One component is hydrogen bond donor and other is hydrogen bond acceptor. So it is a very simple chemistry where we are using these type of solvents in any of the energy storage devices, because these are eco-friendly. These are treated as green solvents, eco-friendly solvents, which are being used in energy storage devices. So there are many challenges which are being associated with the common electrolytes which we are using nowadays in one or other energy storage devices. There are many challenges. Now these devices are consisting of course organic solvents, so safety issues are there. Flammability of organic liquid electrolytes is very high. Thermal runaway in high energy system is there in these types of electrolytes which are being used in one or other type of energy storage devices. There may be certain gas evolution which is creating pressure and leading to explosion of the battery, and there are many other problems associated with leakage risks in liquid systems which we are using in various energy storage devices, including lithium-ion batteries. So earlier we were talking about that we can substitute these harmful solvents by aqueous electrolytes, but again there are certain problems that aqueous electrolytes are not so much efficient because of the less electrochemical stability window, which is one of the very important requirement for any of the efficient energy storage device. So we cannot simply substituting the organic solvents with aqueous electrolytes so as to get the efficiency in lithium-ion batteries. So there are other challenges which are being associated with the common electrolytes, which I have already talked about. That solid electrolyte interface is one of the very important phenomena which is basically keeping our battery healthy. But when this interface is creating a lot of resistance for the movement of lithium ions from one electrode to other electrode, then again there is a problem. So we have to overcome that problem by substituting the existing solvents with some other solvents which are not creating high resistance to the flow of lithium ions. So there are many other limitations, including ionic conductivity, chemical and thermal stability, cost and scalability. So all these issues are there for the common electrolytes which we are using, and on the one side they are giving good results, but on the other side they are creating a lot of problems, leading to explosions, leading to various types of pollutions also, and are highly thermally unstable, highly flammable, and may posing many risks on the human beings. So all consumers which are using electronic gadgets, they are thinking, moving to the lines that they should use certain eco-friendly devices. Whatever device they are using, they should not create any problem to any of the resource, maybe land, maybe water, or any other type of resources. So there is a need to devise other alternate solutions for replacing the existing one. So why do we need sustainable and hybrid electrolytes for energy storage applications? Because we need now efficient, eco-friendly, safer, efficient solutions which can replace the existing solvents which are being used in electrolytes in lithium-ion batteries or other energy storage devices. Now so we should look for new electrolytes which have high electrochemical performance, including ionic conductivity, having large wide electrochemical stability window, and their charging rate should be very less, discharging rate should be very high. Only then we can think of the efficient electrolytes which can replace the existing one. Also, we should also explore the electrolytes which must have wider electrochemical window. Environmental compatibility, I have talked a lot about it. Enhanced safety, we should work on. We should look for the electrolytes which should not create any harm to anyone, including environment. So we should also work on the ionic conductivity parameters, because for efficient electrolyte, ionic conductivity, viscosity, density, all these physico-chemical parameters are very, very important in deciding the efficiency of any of the electrolyte. So these parameters are very, very important when you are planning to work on these areas. So you must explore the possibility, you must go through in detail about the physico-chemical parameters, which have been very, very important for any of the energy storage devices. So that's why there is a need to switch over, shift from common electrolytes to hybrid electrolytes, because common electrolytes may have many problems, including high flammability, limited voltage window, limited conductivity, and costly affair. So we cannot go with the common electrolytes. Rather, we should explore the possibility of new electrolytes, which are basically hybrid electrolytes, which are consisting of eco-friendly solvents, so that those electrolytes can work efficiently and should not pose any harm to any of the natural resource. So this is also one of the trends you might have seen, or I have just collected this data, that there is a trend in green and sustainable electrolyte research. So when we go to the Google and search for certain keywords, so we have found that maximum searches were there for green electrolytes. Means now scientific community, they are looking towards green electrolytes. They want to substitute the existing harmful and unsafe solvents which are being used in the current energy storage devices. So there is a move, there is a shift towards green solvents. Combinations which me and my group has explored, that let us see the possibility how we can create, we can design, we can make hybrid electrolytes by using common electrolytes. ऐसा नहीं है कि मैं कहीं बाहर की दुनिया से कुछ इलेक्ट्रोलाइट्स लेके आऊंगा, मैं एग्जिस्टिंग इलेक्ट्रोलाइट्स को ही यूज करूंगा, जिनको मैं कॉमन इलेक्ट्रोलाइट्स बोलता हूं. उन कॉमन इलेक्ट्रोलाइट्स को मैं थोड़ा सा मॉडिफाई करके परम्यूटेशंस एंड कॉम्बिनेशन लगा के एक इलेक्ट्रोलाइट की कुछ खूबी लेके दूसरे इलेक्ट्रोलाइट की कुछ खूबी लेके दोनों को मिलाऊंगा, एंड आई एम क्रिएटिंग ए हाइब्रिड टाइप ऑफ electrolytic system or electrolyte for energy storage devices. So these may be aqueous plus organic electrolytes, aqueous plus gel electrolytes, ionic liquids and organic electrolytes, ionic liquids and gel electrolytes, deep tactic solvents, organic. There are many combinations. I am also using ionic liquids. I am also using deep tactic solvents. I am also using aqueous system. I am also using certain additives also, because I am trying to use bioadditives which are basically eco-friendly and are not posing any harm to the health of the battery. So I am also trying to add certain bioadditives also. I would be showing you the work which my group is working on. So this is the one of the problem statement which we have taken, that we are using hybrid aqueous and non-aqueous electrolytes. So our research group, basically they are working, they have investigated by using LiTFSI. This is one of the very important salt of lithium which is being commonly used in lithium ion batteries, and using aqueous and non-aqueous electrolytes to understand their physico-chemical and electrochemical behavior. So I started with a very simple problem. I took this lithium salt which is prominently used in lithium ion batteries. Then I started creating a hybrid electrolyte by dissolving that salt in water, and then I tried to check their physico-chemical properties, including viscosity, ionic conductivity, electrochemical stability window, and many other parameters by using spectroscopy techniques also. So there are certain findings which we have coming after doing this work. So apart from using this aqueous plus lithium salt, I also used one of the organic solvent, because we cannot absolutely completely substitute organic solvent. Organic solvent is very, very important in giving us very good electrochemical stability window. So it is not easy to completely substitute any of the organic solvent, but it is easy, or it is feasible to reduce their concentration, to reduce their amount in creating hybrid electrolyte, so that at least we can reduce certain risk health of the battery. So there are many good results which we have found. That electrochemical stability window has been increased when we added the existing ecosystem with ACN, and also connectivity has also been enhanced, and this is also creating, we have also created this type of electrolyte for this lithium-ion battery. So this work has already been submitted to one of the journal. Next. So, dear students, this is the other area where I am exploring the use of ionic liquids. So, ionic liquids are also very, very important. They are somehow being treated as the green solvents. They are less flammable. They are thermally stable as well. So, I am also trying to use ionic liquids as one of the replacement of organic solvents. So, then again, I have used certain salt of lithium, and I have created this ionic liquid, and I have studied various electrochemical and physico-chemical properties also. Next. So these are the key findings of this work, that conductivity, viscosity and electrochemical stability, they have been analyzed, and we are able to get 3.32 millisiemens per centimeter conductivity and electrochemical stability window of 3.24. So means we are reaching to a window where the battery can work efficiently. So two very important parameters, that is ESW as well as conductivity. So we are able to reach to that range, because one of the good and efficient energy storage device works in the range of ionic conductivity 1 to 10 millisiemens per centimeter inverse. So this is the work which has been published in very good journals of ACS. Both the areas which I have explored. So both these areas are being published in reputed journals of ACS. So you can see the images of this work. And these are the recent publications of maybe of last year or this year. I am not able to see the year. 25. Next. Then, dear friends, I have also explored the possibility of using deep eutectic solvents instead of ionic liquids, instead of aqueous electrolytes. Now, deep eutectic solvents are also very prominent, which are being used in energy storage devices also. So, I have also tried with this deep eutectic solvents also, and we have studied these systems consisting of various additives also. So, here I was trying to use certain bioadditives, because these bioadditives are also enhancing the health of the battery or health of the energy storage devices in terms of efficiency, in terms of electrochemical stability window, in terms of ionic conductivity, and there are many other good results which have been observed when I have used the deep eutectic solvents along with lithium salt, along with certain bioadditives including amides, amino acids and nitriles. So there are again many good results. I would not be going into much detail. That again we are reaching to very good electrochemical stability window, and we are also able to reach to the the required range of ionic conductivity as well with these solvents which are being used in place of organic solvents. So I am also able to get certain good physicochemical parameters also which are required for the efficient energy storage system. So one of the students has also working on zinc-based electrolytes, which are basically using zinc salt and glycols and forming this deep eutectic solvents. So one of the component is hydrogen bond donor, another is acceptor. So basically they are being used in different ratios, and when these systems are being investigated, so again there were many good results which have been found. Next, please. So again, ionic conductivity as well as electrochemical stability window, they have been achieved of the good range, and various combinations or various permutations which are being used in creating that zinc-based deep eutectic solvents. So we were getting good results in which 1:6 this zinc-based deep eutectic solvents has been found the superior over other which have been. So we have to try different combinations. We have to try different ratios which are being used in hydrogen bond donor and hydrogen bond acceptor. So again, this work has been published in very good journal of ACS. So having PART-5 scores around 4. So again, this work has been recognized. So dear friends, if you go for any of the environment friendly approach in your area, so chances of getting funding, chances of getting published in good journals is very, very high. So try to find trying to work on the problems which are basically helping a common man and which is basically helping environment as well. So I have chosen both, so that's why I am getting good results in terms of publications for the work. So there are many challenges and future research directions when I try to substitute these the solvents which are being commonly used with ionic liquids or deep ducty solvents or many other possible solvents which can replace the existing one. So there are many. So when I was dealing with ionic liquids, as I discussed earlier, that their synthesis cost is very high, they are very costly. So there are certain issues also associated with viscosity, because viscosity is also one of the very, very important parameter. So your electrolyte should not be very, very viscous, because that would hinder the ionic mobility of lithium ions, and that would be, affecting your ionic mobility and would be affecting your health of the battery. So ionic movement of the lithium ion from one end to other end, from one electrode to other electrode, is very, very important if that keep on going, so our battery works efficiently. So there are many, strategies which have been adopted so as to reduce the production cost of the ionic liquids. We are also trying to explore other sustainable methods where we can use these ionic liquids as a in very small amount, along with other solvents or along with other additives also. So challenges with deep ducty solvents also, which we try to use by replacing the existing one. So again, there are many problems which we encountered with. So it is not so easy to design, to fabricate, to prepare deep eutectic solvents. So sometimes this DS is not being forming in various conditions which we are doing in the lab. So there are many problems we are encountering with, but we are finding the ways how we can prepare these deep ducty solvents for the energy storage applications. So these are the challenges which are being associated with the hybrid electrolytes as well. It is not so easy to replace the existing organic solvents with the hybrid electrolytes, because there may be many problems including high interfacial resistance, fabrication complexity, limited room temperature conductivity, dendrite growth. Dendrite growth is also one of the very, very important phenomena to understand. This dendrite growth is taking place in the battery during charging and discharging process. So uneven layer of lithium metal starts growing on the anode. When lithium ions are being migrating from cathode to anode, so by the reduction process, lithium ions are gaining electrons and they start depositing on the layer, forming a layer on anode. So basically, sometimes that layer is uneven and creating. Sometimes it is hampering the workability of the electrolyte and battery as well. So. Thanks to my research scholars, this is my team, those who are working in various problem statements, and I am so thankful to my scholars, Akshay, Renuka, Akhil, Shivani, Udit, and they are doing wonderful work in the labs and we are getting very good results. I hope you might also come in with certain ideas after this lecture that we can work on a very simple problem which can help society at large, which can also help preserving our resources also, and only then we should feel proud that we belong to a scientific community. So let us contribute towards society. Let us work on the problem statement which could be reaching to a common man. Only then there is the use of doing certain research work. Thank you so much.